Ayo.
Last one, number 9, and we done. 9, by the way.
Yeah.
9. No, it's 9. There you go.
So, the combined gas law.
Math, I love it.
Yeah, I'm gonna let him do math. I hope he does it slow enough for you to follow along because he's amped on coffee right now.
Yes, and I will do it both ways.
Mm-hmm.
But first,
temperatures during the combined gas law always have to be in Kelvin.
Yeah, there is something that we actually skipped and we haven't talked about. And back in MCAT, change in temperature is the same in Kelvin and Celsius. I don't really need to convert. You guys can take it and do it yourself. And I've had one student do it already. Go to 0 degrees Celsius to 100 degrees Celsius and calculate the change in Celsius. And then convert both of those numbers into Kelvin and tell me what the change in Kelvin was. And you're going to find out that the change is the same.
The units are the same size. They just start at different points.
Yeah, we like to say they're on the same staircase. We start on the different floor.
Right. Now, the issue in this combined gas law equation is that temperature falls into a denominator.
Yeah.
So your temperatures must be in Kelvin because there's no such thing as 0 degrees Kelvin. If you use 0 degrees Celsius in your calculations,
denominator,
your math doesn't work.
Yes. So besides, we're also going to talk about total energy, and the Celsius scale doesn't talk about total energy.
Right.
We're talking about all energy here. So we do need to be in Kelvin. So that's number 1.
The pressure units don't really matter.
No, well, all you need to know there is pressure and volume just need to jive. Mm-hmm. What I got on one side of the equation, I need to have on the other side of the equation. It doesn't matter as long as they're the same unit.
Absolutely.
And we won't be playing games of making you convert back.
The combined gas law compares before and after, initial versus final. So like assuming we have a container with gas in it at a certain temperature, pressure, and volume, and then we change something like the temperature, the pressure, or the volume.
Yeah.
What would the other two terms be?
Yes.
We change a couple of the terms. What's the final term going to be?
Yeah, this is going to be a plug and chug where 5 of the variables are going to be given to you. You have to find the 6th one. And you need to be able to apply STP. So if we tell you we start at STP, you know the starting temperature and the starting pressure.
Correct.
So then you need to be able to put those in. We give you the starting volume. Mm-hmm. Okay, so those are really the only tricks. You know what we didn't do either?
What?
With the guy Lussac, did I say right?
Yeah.
With his law and Charles' law and Boyle's law.
Right.
We didn't break them down this PTV, did we?
Nope, we didn't because those 3 laws were combined to make this law.
And guess what? Those ones aren't in the reference table.
Nope.
So we only need to do it here. Let's do it.
So the volume of a sample of gas at 273 Kelvin and 5 atmospheres is 150 milliliters, okay? So what Mr. Milks is going to do is he's going to write his initial equation, P1 V1 over T1 equals P2 V2 over T2. Now I'm going to suggest that he picks up the red pen and circle the initial P1, V1, and T1. So gas at 273 Kelvin, that's T1, write it over the top. Yeah. 5 atmospheres, that's pressure, so that's P1.
Gotcha.
And 150 milliliters, that's volume.
Can I plug him in right now while I'm there?
Sure. He's going to write it halfway. So
times PV.
150.
Yep, 150.
Divided by 273.
273. Gotcha.
Is going to equal the after conditions. Let's do these in green.
Gotcha.
So we're going to find the volume is decreased to 100 milliliters. So that's V2.
Okay.
The pressure is at 3 atmospheres. So that's P2. What is the new temperature of the gas?
So I got P2 and V2 up top. That's 100 times 3.
And the new temperature of the gas is X. You need to solve for T2.
Yep. Now, here's one piece. You guys can hear me over there. Now we have the equal sign, which we didn't have last unit.
Nope.
So now I can cross multiply.
Mm-hmm.
Right?
Yep.
All right, so cool. So that if I cross multiply, I'm going to have
273.
5,
Yep.
5 times 150 times
T2 equals
273
times 100 times 3.
Now the order doesn't matter as long as you keep the right ones on the right sides, right?
Correct.
Okay, cool.
So he got to get T2 by
So
itself.
I'm going to divide by 5 times 150.
Correct. Both sides.
Divide by 5 times 150.
150 and 5 over here
T2.
cancels out.
Yes, I got you. Go for it. I'm going to switch. So this
Those
cancels,
cancel.
and I'm
They turn
all left
into
with what I want.
mathematically 1.
And then I basically just need to plug all the rest of this in the calculator. And if you either got to put these in parentheses or press equals after that, and then you can divide by those.
Mm-hmm.
and you need more parentheses, and then you're going to get a number right there.
Mhm.
Now, some of my students left that blank last time.
Ooh.
It's
Not
very
full
easy.
credit.
No, not full credit.
Now, what are the units of temperature going to be?
Oh, good question. I'm thinking it's the units that was given to me.
And furthermore, temperature with combined gas law always is in Kelvin.
Sweet.
So there is your first taste. You do the math.
Yeah.
We'll do another example.
You got a calculator. Use your phone. I don't care.
So finding final volume. Same exact process. P1 V1 over T1 equals
Okay.
P2 V2 over
Bang, bang, bang. This is V1,
T1
T1,
P1.
Okay, can I put those right in?
Yep.
Oh, I lost it though, but it's P1 V1. So
Over T1.
so
So
it's 4
times 2 divided by 346
Okay, do it.
equals, what's the new volume if the temperature is changed and pressure drops to 1? So we know the new temperature, T2, and the new pressure, P2.
P2.
We have to figure out
So I have
V2
1 times V2
over
over
273.
273. Okay, so this is where I'm going to take the opportunity to show you a trick. So a shortcut, right? Milk's method on a problem like this. I know that if I multiply a fraction by its reciprocal, it equals 1. Then if you do this enough times with the crisscross method, you're going to find out it does work out to be the exact same thing. So what I'm going to do on this time is I'm going to multiply this fraction by 273, if I can spell, if I can write right, by 273 over 1. And when I do that,
You got to do it to the other side too.
I'm just going to go ahead and cross off that side first. Whatever I do to one side, I have to do to the other side.
Yep.
And that is going to be the result of my cross multiplication anyways.
So let's write it out for him at one time.
So I got
V2
V2 is gonna
equals 273 times 4 times 2 divided by 346. And your units for volume 2 will be the same units that you were given for volume 1.
And so that is
Liters. It all
And-
just works out.
So
I like your method. I hope that my students understand that multiplying by a reciprocal cancels one out,
Sure.
and that they don't freak out when it's not cross multiplication.
Right.
Either method that you use will get you to the same answer.
But and here's the thing though, if you were to cross multiply like we did in the last example, you still will get this. I promise. This is just a shortcut.
It is. And it's good math.
Yeah.
Absolutely. Multiplying by a reciprocal. So I think we have one more example to show.
Let me get rid of this. Okay.
Final pressure giving final volume and temperature. So
Okay.
again,
Ooh.
identify your variables. There's
V1.
volume 1.
And then
STP.
Oh, so that is going to be my P1 and my V1. Let me
And
just
now
do that.
P1 is pressure 1. Let's use 1 atmosphere. I like the
All right.
number 1 when we do
All right, so we're
math.
going to fill it in. So V1 is 20, and then we're talking 1 atmosphere
Yep.
over 273 Kelvin.
Kelvin.
That's standard temperature and pressure right there.
Absolutely.
Okay,
Equals, well, what's the final pressure if the final
Heated
volume is
to
100
this.
milliliters?
And a volume of this. So here's my V2, and this is going to be my
T2.
T2.
So we're
A
going
little
to
bit of
figure
reading
out
comprehension. So we're
P2
good. I got 100 milliliters over
times
P2,
2. Yep.
all over 398. And so this time I will go ahead and cross multiply.
You're going to do it that way? I
I'm gonna-
liked your other method. That was cool.
I do like my other method, but I'm gonna
that's
I'm
cool.
gonna cross multiply because I have a feeling that they would. A lot of kids are comfortable with what they know. I promise you that you do it enough times, and what you actually do with this is save a step. But so now 273
You were bad that today.
times 100 P2.
Yep.
And, then I
And
gotta
this is the
divide
step
by
that he's saving when he multiplies by the
273
reciprocal.
times right. This step right here, when I have to divide both sides by that, 273 times 100, and these cancel and these cancel, leaves me with this.
So P2 equals 398 times 20 times 1 over 273 times 100. And the volume, pressure in this case is going to be in atmospheres because the pressure at STP is 1 atmosphere.
Yep, so that's atmosphere. So
Blank.
P2 is going to be blank.
ATM.
ATM.
And we're almost out of time. So I hope you've been spending your time correctly. Video, practice, check it, move on. Video, practice, check it.
Like that.
See you next unit. A click